Let's learn how to derive the quadratic formula. As always, remember to download the corresponding PDF using the link in the description so you can follow along as I work through this derivation. In algebra class, we teach students to solve quadratic equations like this by one of three ways: factoring, completing the square, and with a quadratic formula. But the truth is, the quadratic formula and completing the square are one and the same. So I've included the steps for completing the square from my completing the square video for reference, along with a couple of properties of radicals and the piecewise definition of the absolute value function. We're going to use the process of completing the square to derive the quadratic formula we should all be familiar with. So let's get to the derivation. We're going to solve a generic quadratic equation for x. The first assumption we're going to make is that the leading coefficient a is positive. We can make that assumption because if it wasn't positive, we could just multiply the whole equation by -1 and have a positive leading coefficient. For example, -5x squared plus 2x minus 1 equals 0. This quadratic equation has a negative number for the leading coefficient, but we could just as well multiply this entire equation by -1 and get an equivalent equation, 5x squared minus 2x plus 1 equals 0. Now we have a positive leading coefficient and the solutions will still be the same. So this is a completely reasonable assumption. Now let's proceed using the completing the square procedure. The quadratic is already in standard form, so we don't need to do anything for step 1. Step 2 says factor out the coefficient of x squared. For us, that's going to be a. So we'll factor that out. A times x squared plus b over a x plus c equals 0. The third step is to divide this coefficient by 2. B over a divided by 2 is b over 2a. Step 4, put a box around that for later. Step 5, we're going to square that number. B over 2a squared gives us b squared over 4a squared. And for step 6, we're going to add and subtract that number inside our parentheses. So we have a x squared plus b over a x plus b squared over 4a squared minus b squared over 4a squared, close parentheses, plus c equals 0. For step 7, these three numbers should factor nicely. A times, parentheses, x plus the number in the box, b over 2a squared, minus b squared over 4a squared, close parentheses, plus c equals 0. Step 8 will distribute a to both of these terms. A times x plus b over 2a squared minus a b squared over 4a squared plus c equals 0. Now if we look at this term, we have an a in the numerator and a squared in the denominator. That can simplify to a single a in the denominator. A x plus b over 2a squared minus b squared over 4a plus c equals 0. And now we've made some progress in that we only have x showing up in one part of the problem. So we're going to isolate this expression, a x plus b over 2a squared equals, add this term over, b squared over 4a, and subtract the c, minus c. Now let's combine the two terms on the right side of the equation into a single fraction. We'll need a common denominator to do so, so we will multiply the negative c by 4a over 4a. And now our equation looks like a x plus b over 2a squared equals b squared minus 4ac all over 4a. The b squared minus 4ac should start to look familiar. Remember, our goal here is to solve for x. So now let's divide both sides by a. X plus b over 2a squared equals b squared minus 4ac over 4a squared. Now we'll take the square root of both sides of the equation. X plus b over 2a equals, on the right side we'll have plus or minus square root of b squared minus 4ac all over 4a squared. Now it's just one step to get x by itself. Subtract b over 2a from both sides. X equals negative b over 2a plus or minus square root b squared minus 4ac all over 4a squared. Now we'll apply our first property of radicals that says we can apply the radical to both the numerator and the denominator in this term. So x equals negative b over 2a plus or minus the square root of b squared minus 4ac over square root of 4a squared. And that means that x equals negative b over 2a plus or minus the square root of b squared minus 4ac. We'll apply our second property of radicals that says we can write this denominator expression as two different radicals. Square root of 4, square root of a squared. So we have x equals negative b over 2a plus or minus the square root b squared minus 4ac over 2, and the square root of a squared is the absolute value of a. You can refer to my video on the square root of x squared to see why that's the case. Finally, we can refer to our definition of the absolute value function to replace this absolute value of a expression. The absolute value of a will be equal to a if a is greater than or equal to 0, and negative a if a is less than 0. Our first assumption was that a was a positive number, so we can swap out this absolute value of a with just the regular value of a. Negative b over 2a plus or minus square root of b squared minus 4ac all over 2 times positive a. And you can probably see the last step here. Just combine these two fractions. X equals negative b plus or minus square root of b squared minus 4ac all over the same denominator, 2a. So every time you're using the quadratic formula to solve a quadratic equation, you are completing the square. You just didn't know it. That completes our derivation. So if you found this video helpful, make sure to like and subscribe for more math tutorials. And if you have any questions, drop them in the comments or join us on Discord. Links are in the description. See you next time. God bless.